The city of Pittsburgh, a place often recognized and defined by one of our most iconic features, our three rivers. The Allegheny River flows from northern Pennsylvania up through New York and down to us here in Pittsburgh. The Monongahela winds up through West Virginia, comes into Pittsburgh, meets the Allegheny at the point, and those two rivers flow into the Ohio River and exit the state. Our waterways are connected. That's kind of one of the most important things to keep in mind when we're talking about watersheds. And talking watersheds, that's exactly what we're going to do in this video. We'll find out what a watershed is, what does one mean when they're referring to a watershed, how is an urban watershed different from less modified watersheds, what are some of the challenges of managing infrastructure in an urban watershed, and what's unique to Pittsburgh's situation? What do we do here at Pittsburgh Water to better manage our stormwater and to protect our watershed? So, watersheds. What exactly does it mean? We hear the term a whole lot, but it's more than just waterways. Watersheds include the land that surrounds waterways, which flow to larger waterways. When it rains or snows at elevation, water, of course, has to go downhill. In functional terms, this means it's going to go to one side or the other. If you think about the elevated ridges and hills in an area forming the ring of a bowl, and the bottom of the bowl is where all of the water that falls is going to collect, it's a container, you've got the right idea. We all live in a watershed, and the term is really a geographic descriptor, meaning it can tell you a little bit about the place that you're in. When trying to define what watershed you're in, if you're looking at a map, it's really a matter of scale. You could talk about your smaller local watershed or your larger encompassing watershed, and it would be correct to say you belong to both of those watersheds at the same time. Just like in this example with standard political maps, it might be correct for me to say I'm a resident of the city of Pittsburgh. I could simultaneously say, because Pittsburgh is a city in the state of Pennsylvania, I'm also a resident of Pennsylvania. And of course, Pennsylvania is a state located in the United States of America, so at the same time, I'm also a resident of the US. All of those things would be true. And so it goes with watersheds. Maybe my property is a piece of land where every time it rains, that water will eventually make its way to Pine Creek. Therefore, I live in Pine Creek watershed. Now, the water from Pine Creek eventually will flow into the Allegheny River. So, I also belong to the Allegheny River watershed. The Allegheny, as we know, empties into the Ohio River here in Pittsburgh, and the Ohio River Basin captures an astonishing 69 million acres of land drainage before it links up with the Mississippi River. The water cycle. This is the basic process through which water can move through the environment, and we might remember this from school. The basic processes here include evaporation, whereby the sun's energy heats liquid water on the Earth's surface. Evapotranspiration is a word that refers to all of the water that's moving from the surface up to the atmosphere. This includes water that's evaporating from streams, lakes, as well as things like trees, plants, and soil. Once in the atmosphere, water condenses or gets a little closer together, forming clouds. And if the conditions are right, you have precipitation, rain, or if it's cold, snow. Now we return to the part of the water cycle where water is obviously interacting with the land again. Starting with infiltration, this one's important. Infiltration is the process by which water is percolating into the ground, slowly moving through layers of soil, recharging groundwater. Though we're often looking at 2D maps of watersheds, it's important to note that this is a hydrogeologic deep dish. There are layers that go into the ground that are very important to the functioning of a watershed. In a less modified or less changed by human activity watershed, Water infiltrates into the ground slowly and deeply. It recharges groundwater as it's supposed to, feeds the streams, the rivers, plants, trees, and runoff is reduced. Runoff is the process by which water moves quickly because the volume of water is greater than what can be absorbed by the land at that time. In a natural or less modified watershed, runoff isn't as big of an issue as you might find in places that have been heavily changed by human activity. In a less modified watershed, there's plenty of absorbent surfaces to pull water into the ground and ensure that it doesn't become runoff in the first place. There's an area of land in the upper Allegheny River watershed known as the Allegheny National Forest. In the Allegheny National Forest, layers of absorbent organic material like peat moss and humus are thick, sometimes several feet thick, in fact. When you start to think of a whole forest filled with this stuff, you can imagine how much localized flooding it mitigates and how much pollution it could filter. When waterways are unmodified, they're more likely to have their natural buffers intact or the areas of land leading up to the edge of the water. Unmodified floodplains allow water to expand and contract as water levels change and precipitation events happen. A floodplain is meant to flood quite simply. In an unchanged or more natural system, there's no buildings on these areas to become damaged when that natural flooding happens. In an urban watershed, or areas that are often heavily modified by human activity, things are a little different. One of the most pronounced effects in an urban watershed is a difference in the ratio of infiltration to runoff. In cities, we have plenty of paved surfaces. There's roads, parking lots, roofs, houses, a lot of surfaces that don't allow water to infiltrate deep into the ground. This water, which would otherwise infiltrate, can then become runoff. It can move very quickly over the ground because there's nowhere else for it to go. The volume and velocity of stormwater in cities tends to be higher than you might find in a more natural system. This can create a number of challenges for a city's infrastructure, inhabitants, and the watershed. We've really changed the natural flow of water in our city since it industrialized. What used to be an area riddled with runs and streams is now suspiciously devoid of these tributaries. So, where exactly did all of this water go? Well, in the 19th century through the early part of last century, many of these streams, which were inconvenient to all of the things that we were building at the height of the Industrial Revolution, and which were sources of waterborne illness due to the levels at which pollution was entering the waters at this time, were shunted underground into sewers. Streams were culverted and confined, and in some cases, buried outright. But waterways have a memory, and water always finds a way. It's no coincidence that some of the flooding we have in the city today are areas where there were relic streams. To make matters even more complicated for our urban watershed, as we built our city out, we also lost much of the woodland cover that would have protected the stream banks from things like erosion. Erosion, or the process of sediments moving from one place to another, is greatly increased whenever woodland cover is removed from a stream. There are fewer tree or plant roots to hold the sediments back, therefore, they make their way into the water where they can affect water quality, the health of aquatic life, and also contribute to flooding. Pittsburgh's a pretty old city, and that certainly applies to our infrastructure. Our earliest sewers date back to the 1840s, which is 20 years before Abraham Lincoln was president. A significant portion of our city's sewer system was constructed in the early part of last century for a variety of reasons, which included things like cost, topography, available materials, construction capabilities, and several other factors. We ended up with a system that today is largely what we would consider a combined sewer system. This is in contrast to a MS4 or a municipal separate storm sewer system. In a combined sewer system, which makes up 75% of Pittsburgh's system, wastewater and stormwater is shunted into the same sewer. Those sewers have a structure that regulates flow, sometimes called a dam or a weir, which in dry weather blocks the flows from overflowing into the rivers and waterways. That water is directed to the wastewater treatment facility, in our case, Alcosan. The problems with the combined sewer system really come to bear when there's wet weather. When it storms in a combined sewer system, stormwater flows and wastewater flows mixing together in that same pipe can easily overtop that weir or that dam structure and overflow into waterways, carrying untreated sewage and pollution. This is not a bug of the system, it's actually a feature. The system was designed this way on purpose to avoid stormwater and wastewater backing up further into the pipe, going into people's basements, and causing damage to infrastructure. The casualty in all of this, however, is of course our waterways. As little as 1/10 of an inch of rain in Pittsburgh can cause a combined sewer overflow. This affects water quality in the greater watershed as a whole. About 25% of our system is that municipal separate storm sewer system, the MS4. What this means is the stormwater and wastewater are in separate pipes. When wet weather comes to an MS4 system, it's a much better situation. Wastewater enters a separate sanitary sewer and is directed to the wastewater treatment facility. Stormwater enters a separated storm sewer. Theoretically, there shouldn't be anything in there that we wouldn't want to go into a waterway, as it does still outfall. This is why it's especially important to monitor and to make sure that pollution is not entering the storm sewer system, because whatever goes down a storm drain when it rains in an MS4 could very well end up in your nearby stream or river. While combined sewer systems aren't a Pittsburgh specific thing, they definitely do cluster in the upper Midwest and Northeast, with the older cities. Managing sewer sheds, sewer infrastructure, and stormwater in an old city like ours is no small task. It's a task that requires constant diligence. And given the many unique factors of our urban watershed, including changes we've made to the landscape and changes that are yet to come from factors like climate change, there's a lot to do. For all of these reasons, we are doing our best to manage stormwater, protect our natural environment, and improve the health of our watershed. We know that investing in sewer projects that improve reliability of the sewer system and longevity of the system are incredibly beneficial to the city, but they're also beneficial to the watershed. Every repair, replacement, or upgrade to make sure that wastewater goes where it's supposed to also ensures that wastewater isn't going where it's not supposed to. Repairing breaks, cracks, and general degradation to sewers helps to stop pollution from leaking out into the groundwater. Projects to right size and upgrade our sewers help us to match what's needed for wastewater and stormwater flows today. And any projects that can move more of our sewer system to an MS4 system instead of a combined sewer system obviously help our waterways. When it comes to stormwater, there are a number of interventions we can take to better manage stormwater flows. We now have a good understanding of what some of the challenges are here in Pittsburgh. So, what are some of the solutions? Green infrastructure projects, and there are many that Pittsburgh Water has, over 2 dozen in fact, do a lot for stormwater management. Stream stabilization projects like this one, which took place at Sawmill Run, help to reduce erosion. When erosion is reduced, those sediments have less of a chance of clogging up the stream, causing flooding, polluting the water, and changing water quality for the worse. Huge soil nails are driven into the stream bank that's been denuded, and this serves the role that big, deep tree roots might have served if the trees were still there. Many of the components used in our green infrastructure projects have the goal of reducing the speed and velocity of stormwater runoff and preventing pollution. Underground stormwater retention, like this project seen here along Braywood Way, provides extra space for stormwater runoff to collect instead of pooling on roadways, like was the case on Braywood Way before this project. Bioswales, stormwater bump outs, and rain gardens, like those seen here at Lawn and Ophelia, Whiteman Park, and Volunteers Field, allow water to percolate more slowly into the ground and collect runoff from roadways and sidewalks. Interventions like these are great at mitigating pollution, and they also prevent basement backups for our customers. The idea behind green infrastructure projects across the city is that the whole is greater than the sum of their parts when it comes to the health of our watershed. There are many other things beyond what I've mentioned here that Pittsburgh Water is doing to protect the water as well. Things like our environmental compliance team following up whenever there's an illicit discharge report to our sewer system, or keeping an eye on construction sites to make sure that concrete doesn't end up in a storm sewer. All of these things we do to be good stewards of our watershed. Because waterways connect, our commitment to protect waterways up here affects everyone downstream from us. Pittsburgh Water is a member of ORSANCO, the Ohio River Valley Water Sanitation Commission. ORSANCO and its member states, which are located along the Ohio River Basin, work collectively to promote values of stewardship for the entire watershed. And as a northerly member, we set the tone all the way to the Mississippi. If we're talking watersheds, what happens in Pittsburgh doesn't stay in Pittsburgh.